Hello everyone, my name is Surya and welcome back to my channel. In today's video, we are going to dive into RBAC and I will explain what it is and the different components of RBAC and share some real world use cases. Plus, we will go through a hands-on practical demo so that you will understand the concept better. If you are new here, don't forget to subscribe and hit the bell icon. In role-based access control, there are two levels of permissions. One is at namespace-scoped and the other one is ClusterScope. So in the namespace-scoped, where you will use role and role binding and you control permissions for resources within the specific namespace. When it comes to the ClusterScoped, where you will control the resources across the entire cluster. For that you will use ClusterRole and ClusterRole binding. This gives permissions at the cluster level. Before we deep dive into RBAC, let's understand why it's important and look at a real use case. Imagine you are working on an online e-commerce application where it involves multiple teams such as dev and QA. To manage their work, you create a namespace for dev, for example ecom-dev, and you create another namespace for QA, for example ecom-QA. And you also have a namespace for production, for example ecom-prod. The production namespace is sensitive and we restrict access to it. Dev and QA teams should not be able to modify anything in production. Instead, dev team will have permissions in ecom-dev to create or delete deployments, and for QA team will have permissions in ecom-QA to run their test cases. We don't give full access to everyone because if dev or QA accidentally delete resources in production, it could impact the entire project. So we use RBAC to restrict their access. Dev and QA work only in their own namespace while production remains protected. Let's start with the namespace-scoped and understand what components are associated with it. At the namespace-scoped level, you basically have a role, where role defines the permission, for example what actions are allowed. These actions could be anything like reading pods or listing pods or create pods or delete pods. You can define these permissions inside this role. Once you have the role, you can attach it to different entities. You can attach it to a group or user or service account. For the group, it could be a QA team group such as ecom-QA, or it could be a user to a specific person, or it can attach to a service account, which is like an identity for pods. The next component is role binding, where it defines who gets the permissions that you have set in the role. This could be a QA team or dev team or even a specific service account. Now let's understand service accounts and their real usage. As I mentioned before, service account is like an identity for pods. You create service account for different use cases such as when a pod needs to communicate securely with the Kube API server or other services. You can attach the role to the service account using role binding. Later you can attach this service account to the pod itself. Don't worry if this sounds a bit confusing right now. Once we go through the demo step by step, it will become crystal clear. Let's talk a little bit about the service account with an example. Suppose you have a front-end pod that need access to the config map. For those who might not be familiar with config map, it is basically a key value stored used to decouple application configurations from the container image. During deployment, your application reads values from the config map at runtime instead of hardcoding them. If the front-end pod needs to read data from the config map, it must have permissions to do so. By default, pods use the default service account in the namespace, which usually has all the permissions. This is less secure because any pod created in that namespace could read the config map, and from a security point of view, it is risky. So instead of relying on the default permissions, you can create a dedicated service account for the front-end pod, and then you create a role that defines the permissions like get and list on config map, and finally you can assign the service account to the front-end pod so that only this pod can read from the config map. No other pods can. And here is the flow that you can follow. First you can create a service account and then create a role with permissions like get and list on config map, and then bind the role to service account using role binding, and then attach the service account to the pod in the pod specification. This is how we securely attach permissions at the namespace level using service account. Next, let's move to the demo. Let's do a quick demo on role and role binding. I will demonstrate this in two ways. For the role and role binding concept, I will use kubectl CLI commands. For the cluster role and cluster role binding, I will use YAML manifest files. And for the demo, we will create a namespace called ecom-dev, and then we create a service account in the ecom-dev namespace, and then we create a role name ecom-dev-full access with the required permissions, and then we bind this role to the service account using role binding, and finally we will verify the service accounts that created in the namespace. First, I'm going to create the ecomdev namespace using kubectl create command. You can see that the namespace ecomdev is created successfully. Next, let's create a service account. I will run kubectl create service account and the service account name and the namespace name. This creates service account name ecom-sa in the ecom-dev namespace. Now let's create a role. This role will have full permissions. After hitting enter, you can see the role ecom-dev full access is created. So now we have service account and role. The next step is to bind them together using role binding. And if you look at the command, I'm using kubectl create and the role binding and the role binding name and then passing the role and service account and deploying this on ecom-dev namespace. Finally, let's verify that the service account was created. For that, I am running kubectl get service account on the ecom-dev namespace. You should see ecom-sa listed under the service account for the ecom-dev namespace. Once the service account is ready, you can assign it to a pod by specifying it in the pod spec. The other level of permissions in RBAC is at the cluster role and cluster role binding level. The scope is cluster-wide, meaning it applies to all namespaces in the cluster. Think of a cluster role as a set of permissions that are defined at the cluster level. When it comes to the cluster role binding, it basically links a cluster role to a user or group or service account. And in short, cluster role basically defines the permissions at the cluster-wide, and cluster role binding will get those permissions across namespaces. Let's understand this with a real-time use case. Let's say you have a Kubernetes cluster with multiple namespaces. Usually Prometheus will run across all namespaces where it will correct metrics. In this scenario, Prometheus is a pod that runs across all namespaces. And Prometheus needs to get the metrics from all namespaces. So it must have access to get the logs of the pods from all namespaces. These are the metrics that Prometheus will scrap from all of the namespaces. These namespaces will have pod, services, deployment, and other resources. This is exactly why Prometheus needs cluster-wide permissions. If Prometheus is running in a specific namespace and you define the role there, it will be scoped to that namespace. In that case, Prometheus will not be able to get metrics from pods running in other namespace. Therefore, Prometheus requires cluster-wide permissions in order to get the metrics. To achieve this, you need to create a cluster role where you define permissions like get, list, and watch for pods, services, and other resources, and then bind this role to the Prometheus service account. Don't worry, I'll show this in a practical demo. So for this demo, the first thing I'm doing is creating a namespace name monitoring. You can see the namespace monitoring is created successfully. Next, I am creating a service account for Prometheus inside the monitoring namespace. So the service account name is Prometheus-sa. After creating it, I will verify whether the service account is created or not using kubectl get service account and the namespace name. You can see the service account is created successfully in the monitoring namespace. Now I will create a cluster role with read permissions across all namespaces. This cluster role will allow actions like get, list, and watch on resources like pod, services, and endpoints. I am using this manifest file to create this cluster role. After applying the manifest file, you can see the cluster role is created. Next, I will bind this cluster role to the Prometheus service account we created earlier. This is done using cluster role binding. The role binding joins the cluster role with the service account. You can see the cluster role binding is created successfully. Now I will deploy a Prometheus pod using the deployment manifest file. It will run in the monitoring namespace, and I am setting the service account name field to Prometheus-sa, which we created earlier. Finally, I will verify the permissions using kubectl auth command to check if the service account can access resources cluster-wide. You can see the response confirms the permissions are working correctly. This is how in real-world scenarios, we provide only the required access at the cluster level, like in this Prometheus example. I hope this video gave you a clear understanding of RBAC and its different components and how it's used in real-time scenarios with a practical demo. If you found this video helpful, don't forget to subscribe to the channel and share it with your friends who might find it useful. See you in next video. Thank you for watching.